Okay. Uh, 11 people out of 21 people. If you're if you're here, please respond to the next poll. Um, then number five. Again, we were supposed to uh, change the order of these words to make a meaningful sentence. So using again keyboard. So basically, you could. This was a good practice to see how you can jump over words by pressing Control and then the left or right arrow. So the first thing that it seems that we should use is the. So cut it, put it there. Again, go up. The probably it was like this. The quick, the quick, the quick what? Onyx. Navin, did you say something? No. Onyx. Again. Goblin. Here. Jumps. Jumps. Jumps over. Jumps over. Right. Jumps over and the rest of the things. I'm not going to continue because I think it's super easy. Jumps over the lazy dwarf. Just a practice to be able to select things and move over words. Um, and then question, I know why do we have two number fives? It's not. Oh, because I copied that there. Go to the end of this line. So for going to the end of this line, we use end. So it is either Fn, right arrow key, or the dedicated end key that you have. Write your name, whatever, and then make all sentences, all instances in this sentence bold. So you had to just go over there, select the word, and then Control B would make it bold. Uh, Again, jump over this, take the other one, bold, Control B, jump over the other one, make that bold. Here it says even more bold. By that we mean make the size. So this is a hint. Figure out how to change font size using keyboard. This is another practice. So how do we change the size? Uh, One way, there are ways like you can press shift brackets to make it smaller or bigger, but one standard way is to access menu items by clicking on alt. Alt shows you the letter that if you press, it takes you to that menu. So here I'm going to choose home, home menu. I want this, right? I want this. So this is FS. So I'm gonna click F, and by F basically whatever you see in the font submenu has the capability of being selected. Everything else has been gone, and also those submenus that that have F in them. But anyways, now it says now font size is FS. So the next thing I'm gonna click is click on S, and that takes me to the size. By changing the size, I will be able to change the size. If you're okay with this, 22 pixels is good. Click on that. Go back to where you were. For underline, again, the same thing. So I'm going to select underline. Control U would underline that for me. Clicking again on U, Control U, would make it normal text. And here for making italics, again, you would say, okay, I'm gonna, I'm gonna click on Home to take my cursor to the very beginning of. Oh, sorry. My FN and my window are very close. FN home, it takes me to the very beginning of the sentence. Shift FN end. And now that I have selected this sentence, I just need to say Control I, right? Control I makes it italics. Uh, the question the question here is, what are the keystrokes to position, select, and perform the text enhancement? Well, for any of these we discussed, and for this one, this was home to take you to the very beginning of the sentence, uh, and then do the shift and end to select the whole sentence, and then Control I to make it italics. Are we good so far? For some people, this is super easy, but consider there are things here that in any course like this, uh, mm-hmm, Himanshi, yeah, go ahead, please. Yeah, sure. The making this italics, is that the one you asked? Okay. So what we said is, imagine this. I want to make it not italics. Now that it's in italics, I want to make it not in italics. So I put uh, I want to put the cursor to the very beginning of the sentence. So what you use for that is you use home key, right? So home takes this to the very beginning of the sentence. Control home takes it to the beginning of the Word document. So I'm just clicking on home, and then click shift because I want to select the sentence. Every time you want to select a sentence or a word, you click shift and then you move your cursor. To move my cursor to the very end of the sentence, I'm going to use end key. As soon as I press while holding the shift key, I clicked end, so it took me to the end of the sentence. And now I want to make it italics, or now that it's italics, if I say Control I is for italics, Control B is for bold, Control U is for underline. So here I want to make it italics. Um, what if I press Control I, because it was italics, it basically undoes that. Now it makes it italics. You can now, I want to say Control B as well and Control U as well. So now it is bold, italics, and underlined. And every time I press, if I want to undo that thing, I'm gonna press the same buttons. Control U makes it underline or undoes underline. Control I makes it italics or undoes italics, and Control B makes it bold or undoes being bold. Are we good? Himanshi, is that okay with you? Now, Himanshi, is it okay? All right, very good. Uh, Thank you, guys. Whenever you have a question, for some people it might seem easy. I know there are concepts that are easy here. There are concepts that are complicated, but overall, we have to make sure everything is aligned and we are all on the same page. Uh, just just interrupt me, unmute yourself, and ask a question. Even if you think that is probably the easiest question ever, but you don't know the answer, it's fine. Please ask. Uh, and then question number 9 says move this paragraph to appear immediately below this. So one way is it says use Alt Shift up down. So Alt Shift up down. When you put the cursor, now the whole paragraph, wherever this cursor, the in a your when you put this cursor and do Alt Shift up or down, the whole paragraph will be affected, not just one line. So I'm pressing Alt Shift up down to take this where I want to put. So imagine I wanted to put it here, so I could easily move this up and down, move the whole paragraph up and down, easily using Alt Shift up or down. Question number 10. Some people got it really wrong. Uh, so I'm going to explain this. So what we wanted here was not only to change the order, basically reorder these sentences in a way that uh, it is in order. It's not in order now, right? So A should come before B. So I'm just gonna take it to A. Again, now that I'm in this paragraph, I can use this Alt Shift up down. Alt Shift up takes it up. A. Now the order is correct. So everybody did this correct. But we also wanted you to adjust the basically same to all these to same style and same size. One option, if you look at this, uh, this format painter, basically this is with mouse, what you would do is select this and then go select format painter, and then that selects the format of this guy, and then you just select this and that does it for you. Once again, format, it changes the format, right? But with this is easy with basically the uh, sorry guys, I need to, sorry, I was actually waiting for a phone call. uh, I just muted it. All right. uh, Now that we are on keyboard, uh, we could use this Control Shift C, but still we want to practice it more. So I want to give this a style that I want. So again, again, I'm gonna press Shift and select this whole sentence, and then I'm gonna go change it to again Alt H from home, then F. It gives me the option to change my font, uh, Times New Roman, for instance. I'm gonna select this. Let's say font size 12 is fine. And for the next one, B, also do the same thing. Select this whole line and basically until the end. So this also needs to be Times New Roman. So again, H, F, Here type Times New Roman, and for again I want to select size. Again you can say H. FS takes you to the size 12. So this is now uh, the same font, except for that this is not bold. So I'm gonna make it also bold. Control B. So now these two texts are exactly the same font and what I wanted. So we didn't say what font or what size. The only requirement was was for all of them to be same font type, style, and size. So that was the missing part for many of you in your activity. Are we good so far? Okay. Are we good so far? Okay, great. For the still I can see some people are not here. Uh, Please respond to these polls. Okay, guys, I can see you. Okay, please reply to the poll, or otherwise the assumption is you're not here. Uh, which doesn't make sense. If you just don't want to be here, you can freely go wherever you want. But when you're here, please be here, and let's make it an interactive class. Thank you. For the last part of the activity was creating again a Hello World program, but this time you were supposed to use keyboard shortcuts for formatting, for commenting, for uncommenting stuff, and basically use IntelliSense. IntelliSense for autocomplete, for suggestions and stuff like that. So I'm gonna go quickly over this and make just create a program here. Uh, let's delete this. Let's delete the whole thing. So you can say exit your solution, so everything goes away. It gives you the option to save because I didn't change anything. I didn't have that option. You can create a new project. These are the things we discussed before. Empty C++ project. I'm gonna save it on my desktop. Say activity activity 2. And then create. It creates the project for me. And from the Solution Explorer, one more time, source files. Now I want to add Control Shift A would do the same thing. So let's try that. Control Shift A creates a Control Shift A. Am I on this? I think I am. Okay. Control Shift A didn't create. Why? It's not creating. New item. Control Shift A. I know sometimes shortcuts. Let's create it this way. And here you give your program a name. Say main. Say main. Create it. Uh, See, uh, for this is basically what we're talking. One features of IntelliSense. Uh, One feature is that if you want IntelliSense to appear and disappear, you can easily, well, the default is it will be there. Every time it's trying to give you an idea of what's going on. And here, basically, if it disappears, if you start writing, it tries to understand what you want to do. But after some time, if you delete some letters and stuff, it will think that you don't need it anymore. So to bring it back, you need to say control a space with the selected word. So one more time, it appeared, control space, brings it in and takes it out, just the way I'm doing, include, and when you're good with that include whatever option, just press tab. It, okay. Now I'm good with this include stdio.h, and then int. See, okay, now I'm good with this int. Okay, let's keep it. Int main, int main. One thing that we wanted you to practice is that every time this IntelliSense basically completes brackets or quotation marks, double quotes every time. So if I put up one, I'm just clicking on one double quote, but it is completing this with another pair, so that I can just easily write whatever I want here, right? Same is with this bracket. It just auto completed that for me. It helps a lot because most of the time it happens with parentheses as well. It does the same thing. Most of the time it happens. You forget to close your bracket, and that creates a lot of problem. Uh, Return. See, again, I have this return here. I press tab, return 0. Then here you can write your program. Just int I equal to 0. Then I want to print this printf c. It just thinks I want to use printf. It allows me to use printf. Printf uh, what printf again, use this uh, counter counter, if I can type, for heaven's sake. Counter is what the this percent d, percent d, probably you know, or you will know, in IPC 144 is a placeholder for an integer, right? Then I'm gonna write it I'm gonna print I and I plus plus. Like, I want to increment, close this. Now there is no, it doesn't show any error. Looks good. So I'm gonna say Control F5 to compile, build and run the program. Control F5 compiles, runs, and builds and runs the program for you. It's taking forever now because I'm doing a lot of things on my computer. It's busy recording, doing everything, and it is that. So you see, this counter is I and I plus plus. So it's been printed over there. We're good with that. But your program is not like this. Your program was supposed to be your name or whatever, but the only purpose was to play with this. Honestly, I was very generous in this one, and almost everybody got full mark. But please go ahead and practice these shortcuts, because it was almost impossible for me to detect if you did this correct. But anyways, almost everybody got full mark here. Okay, this is the end of activity one. Uh, Please let me know if you have any questions up to here. Yeah, please go ahead, unmute yourself, and let me know if you have any questions. No? Okay, and also we had quiz questions. The question that was from previous week, it wasn't just random. We wanted to know if things you learn are the things you keep in mind. Unfortunately, it wasn't the case. Let's take a look at our quiz. So this was the quiz. Basically, well, the order of questions differed from each person, but the questions were more or less like this. So this was a match case. So Control A, we know it's for selecting all. I see it is G. It selects all. Control A. Windows L. L stands for lock. So it locks your Windows, which is lock your PC. So this was A. Control Y, it is the exact opposite of Control Z. When you do Control Z, it means I want to undo whatever I have done. But if you have undone something, or you have done something that you want to redo, that's where you use Control Y. So it redos whatever that has been undone. Control F5 in Visual Studio runs an application. Guys, can somebody unmute and tell me what is the difference between compiling a code, building a solution, and running a code? Can somebody tell me? What is the difference when I'm compiling my code, I'm building my code, and I'm running my code? That's why we have three different shortcuts for them. Control F7 is for compiling only. Control Shift B is for building your solution, and Control F5 is for running without needing to debug the code. Uh, what is the difference between these three things? Any idea? Apparently, no. Okay, so last week we discussed. Let me see. Public chat. Sorry, it was a mistake. Okay, no question thus far. Compiling, basically, Vitali is answering, but Vitali is saying compiling basically saves the code and checks for errors, and running executes the program. Somehow you've got it right and wrong. No problem. Well, actually, it's okay. Vitalik got it right and wrong, but briefly, as Vitalik said, when you are compiling your code, not only it checks for syntax errors, which is the type of error that you make in the format of your coding. We have a standard way of, so it basically is grammar errors. It's similar to grammar errors. When you have a syntax error, it's as if in a language that you're not supposed to put the subject at the end of the sentence, you do that. So that's an error. Compiler doesn't understand that. But it also involves converting that code to machine code. Have you ever thought how in heaven your CPU understands what you type? It doesn't. It doesn't understand anything. Int, nothing. Include something. This is something that you and I understand. Computers do not understand that. So there are there is a process of converting that understandable code which you are writing to a code that this machine understands, which is only zeros and ones. We'll take a look at uh, an a code that has been a solution or an executable file. We will see what the difference is. But it's a scary, guys. If you look at the output of a compiler, it's a scary. It's just zeros and ones, and because you open it with a notepad, it doesn't even that understand zeros and one. It shows you characters, scary characters, gibberish characters that there's no way you can understand that. So the whole process of converting each code module of the code. So you might have different modules in your code, different parts, different sections, right? So a compiler just checks for those errors, and if everything is okay, it converts that uh, to machine code, those gibberish things that CPU understands, your machine understands, you don't understand. Vitali says building is similar to compiling, but I believe it helps with troubleshooting. Kinda, yeah, that's also true. So now that each of these separate modules have been converted to that gibberish code, machine code, we call it, now they need to be linked. We want one solution because this is just a single website, but in that website you might have separate code for imagine this is a shopping cart. You need a separate module or a separate piece of code for adding items to your module, a separate piece of code, a module for displaying items, another one for payment, another one for uh, giving the user the option to select what he or she wants. So one single solution that we see, for instance, in a website or on a website basically, is composed of multiple modules. Compile changes each of those separate codes to machine code. Build checks them and makes it a unified code. And that unified code is something that is a result of combining all those codes. So some part, as you may guess, might be redundant. Linkers are the things that check for those redundancy, eliminate from somewhere, copy paste somewhere, and at the end of the day, they make one single solution out of those multiple different modules. This is build, so compile, build, and the third one is run. Basically, when you run, now after run comes after building. When you do Control F5, basically compile, build, and run. All three steps take place with just one click of a button. Uh, but run basically, which is the final part of this, is okay. Now we have built successfully, we've built our solution. Now I want this to be run on my computer. What does it mean? It means, okay, now I have this somewhere in my RAM. Mr. CPU, go ahead, fetch these instructions line by line. You call it fetching. It fetches the instructions line by line, executes in a CPU, and shows you the result of that. This is very important, not for this course only. From now on, you will be doing compiling, building, and running for all your C++ codes, and anything else that requires a compiler. Like Python is not one of those, for instance. But lower level languages require this compilation. Are we good with the with understanding the difference between compile and build and run? Are we good? If no, then you have to go ahead and ask your question. Okay. Uh, Abdullah, where are you? Jaidan, Shao, Vitaly, Imanshi, Deshdeep, where are you guys? Okay, thank you so much. All right, so let's keep going with our quiz. Control F finds the stuff, so it is C. Control H finds and replaces the stuff, right? Control R runs that small dialog box in your computer. Sometimes it comes handy if you want to run a program. So Windows R is for run an application. So run an application. So what was this? Control F5. Open run dialog box. Sorry. This is open and run dialog box. Control Shift B in Visual Studio. We said that it builds an application. It basically compiles and links. So you at the end of build, you have one executable file. You have the solution basically. Alt tab switches to previously active. So it basically Alt tab gives a view of all the windows that are open and you can select between them. And display D basically takes everything out or displays again on your display. So D is uh, showing or hiding the desktop. Very good. So when dragging files to a folder on a different drive, it is a different drive. If it is a different drive, the default is that it copies. If it is the same drive, it just moves things there because it assumes now this is the same drive. So it doesn't matter if it is in this location or in that location. As long as it is in the same drive, we are safe. So it moves things. But when we go to a different drive, it says, okay, I want to keep a copy for myself, and also I'm gonna copy this file to a different drive. So here, because it's a different drive, the default is copying. Explain what IntelliSense does. Well, this one also many people did correct. IntelliSense in the at the very primary level helps you. It gives you from that drop down menu in Visual Studio. It helps you select whatever you're looking for. It also takes care of all those smart things that is going on in Visual Studio, um, giving you the errors if things cannot be compiled, um and giving you the explanation of later on you will see classes, object, things like that. Later on gives you the definition of those classes, which one is that you want to use. So it does a lot of things. Basically, whatever you answered here was correct, except for some people that said, like, IntelliSense is a very good thing to use. Thank you so much. Thank you so much. That's what we knew. We wanted more detailed answer. You can use Control K and then Control D for formatting. Obviously, that's what we can do. So it was true. Control Control K basically makes your Visual Studio alert. Uh, it makes it waiting for something to happen, for the next command basically. What keyboard shortcut would close the current window? This is Alt F4 for closing the window, and if you want to close a tab on a browser, for instance, it was Control F4 that could close. What is the keyboard shortcut to copy? Easy peasy, like Control C, Control V, and Control X was the answer. Are we good with the quiz so far? Are we good with the quiz so far? Please go ahead. Yep, go ahead, please. Uh, I leave comment. Okay, so some people tell me, did you see? Will you be able to see my feedback? Because I leave feedback for everybody. When you lose mark, you're either 100 without any feedback, or if you are less than 100, you should see something from me. Uh, it says something. Okay, what does it say? Doesn't it tell you which question it is? And oh, sorry, you're talking about, yeah, okay. So you're this is quiz. Okay. So for quiz you don't get a feedback. That's a good question. Let me write it down. Uh Good note. Thank you. You don't see any feedback from me for the quiz. Basically, I should check this and see how we can put feedback there. Okay, thank you so much. I will check this. We'll let you know. What else? All right. Looks like we're good with this. Paul published. Okay, guys. So far we are done with week 2. I want to show you the activity of this week first. This is super easy, but one thing I wanted to explain, I realized even through um, MS Teams, there was not enough interested people for presentation. Listen, this presentation is to make you think about your future. It's very important. Typically, we don't have a clear clue what we're going to do after we graduate. So this is an opportunity. And by the way, it is optional. You know that. It is optional, but not that optional, because if you don't do this, it's 4% of the mark, but I don't really want you to think about that 4% of your mark. This presentation will broaden. This is the basically the purpose. I hope it happens. So it can broaden. It is an opportunity to broaden your view, open your eyes to the world out there, and see what is really going on, what is the latest trend, and what is that you want to do after you learn all these things and you graduate college. Uh, so please go ahead, write your names on this Excel sheet we've put here. So far, if I just open it, you will see some brave people here, uh, and you will not see those people who were reluctant to do this, right? See, only a few people. This presentation, and we had to cancel the presentation for this week. This presentation is nothing but this. Let's take a look. Uh, this presentation is basically uh, talking about yourself. So this is the activity you will be doing for week 3, and this will help you prepare a presentation. It's just a 2-3 minute presentation for each person, and it can even be shorter, but it makes you think about the things you love, thinks about the things you love to do, thinks about the things you don't know even exist, uh, and things like that. So in part one, it asks you to check a couple things, basically a couple websites, to broaden your view, and then come up with a text. And this text is, uh, write your future history. So if this is your future history, what happened to you academically and professionally between now and then, and what is going to be your future? What is that you like to do? Obviously related to ICT. And part two is, again, three different parts. Part two here, if you come down, if I show you the activity, uh, this is activity of week three. So here you will write that text, uh, that is your future, and going through these weblogs, websites, news feeds, and whatever that you like. We just want you to think about it. What is that you like to do in the future? Can you make money out of it? How? Or why you like that? Why you don't like that? What is that you like about it? If you're already involved in some part of coding or something like that. So there are three. It's basically section two, but it is composed of three parts. One, two, three, all same thing, but different priorities. So here, these are all copy paste of the first part, but here you're gonna write, okay, now I saw this trend, I saw this news, I'm interested in this, and give the reference. Talk a little bit more about that. So what did you learn? What did you know? And after seeing this now, what do you think about it? How does it work? How doesn't it work? What is the target? You know, things that you need to discuss here are that, and based on the priority, you put that topic that you are, you're interested in it the most. You put it here, part one. Part two is the second most important from your point of view, and the third one is also something that you like to do but could be your third priority in the future. Go through these, and if you just collect these, if you do this activity, that's basically the presentation. The only difference is that in your presentation, because it is supposed to be kind of a teamwork as well, it is better to find people that you share the same passion with them, you share the same interest, so that you can discuss things more. And in that presentation, uh, you will find these, the points that you both like, and either one of you or both of you or three of you or four people, maximum four people can do, can be in 1 week's presentation. Each week's presentation, four people, and we assume those four people are in one category, one group with same shared interest. But if not, that's totally fine. If you don't find any common interest, that's also totally fine. You can talk about your interests, and at the end of the presentations, we can discuss and compare what you liked and what you didn't like. Does that make sense? And if you have any questions, does that make sense? First is not a Paul question, but if you have any questions, please go ahead and ask your question. If you say yes, it means you have a question. Let's change the way we do polling. If you say yes, it means you have a question, so you have to ask your question. So for the following weeks, maximum four people can present, can basically talk about themselves, their interest, their their whatever they want, actually, their background, if they want, if they have done some coding, if they're familiar with some ICT concepts. uh, some people might even be already working in this industry, so please let us know. This is a fun way of knowing each other, finding similar interests, and let's do this. Just tune your presentation for maximum 2 minutes or 3 minutes if it is an individual presentation. If it is a group presentation, it can take up to 8 minutes. 8 minutes is not much. If you are not if it is not convenient for you to give live presentation, create a video. I'm sure you're probably most of you are good with creating videos. Imagine you're creating a video for a future. Um, Imagine yourself in the future and talk about yourself. Whatever. I know you guys are very creative, so I really. I'm really positive we will see good videos if it is a video or presentations if it is a live presentation. Um, Mudit, what is your question? No, when you write here, if we go back to the Excel, thank you so much. Yeah, very good question. If we go back to the Excel sheet, not this one, the Excel sheet. So basically, I think I have to, I didn't write because I wasn't sure we are gonna do presentation. So this will be week 4. This is week 5, week 6, 7, 8, 9, 10, 11, and I guess we can have two presentation on week 11 because week 13 and 14 are dedicated to our final project. So this will be the week. If you write your name here, that means week 5 is 2 weeks from now. It will be your turn for your presentation. I will give access to you to share your screen and then play your video or slides, anything, anything you want to do. That will be the form of the presentation. Exactly. That's correct. Yes. We have member one, first name, last name, because every week we can have only 4 people, which they may form a group, which is uh, the good way of doing this. You can chat with each other, figure out about your interests. If you know other people from in this class, if not, go ahead and talk. You can even in the public area of our MS Teams, you can post things. Okay, people, I'm interested in this. If anybody is also interested, let's work together. You can do this as well. So use this MS Teams medium as much as you want. Even post on the public area. Public area is not just for me. You can post there. You can advertise your interests and see if anybody else has the same interest. You can ask them if you are interested in working with you. You can work together. Think about these. Well, this really helps you think about future, which is important. So yeah, that's basically how it works. If it is individual, basically 2 minutes, but yeah, we don't mind if it goes about that. So for a week that we don't have enough presenters, uh, your presentation can be longer, up to 5 minutes maximum. Yeah, but typical is 2 minutes, like 2 minutes for 4 people. If we have less people, that time will be like if we have 2 people, you can present for 4 minutes. If just one person, yeah, you can 5, 6 minutes, no problem. Thank you. And Simrat, what's your question? Yeah, as I said, it is optional. We like this to be a group, and that happens if you find a person that shares the same interests with you. Um, and in an ideal scenario, all four people have the same interests. Each can look at that topic. Let's say metaverse. Let's say metaverse. I'm interested in metaverse. If you're all everybody in that week, all four people are interested in metaverse, they can discuss 2 minutes about different aspects of metaverse. uh, how to create an account, what websites we have, what is how can I even enter, what are the differences between these different sites that you can use and build your own metaverse. If you're interested in hardware, talk about sensors that you have to wear, wearable sensors you have to wear to make you able to go there. Talk about backend, like what kind of technology is required, whatever, just whatever. Talk about whatever you want. You need to find, if you find a person that shares the same interest as you, just go ahead. You will be in the team and you can present together, one person on behalf of uh, the whole team, or each person can come when their turn comes and talk about their own part, their own perspective. Or if you're just alone, you didn't find any person that has the same interest as yours, yes, it will be a 2 minute, 3 minute presentation, individual presentation. We will know you, we will know your interests, and some people might give some comments. We can discuss things after that. Did I answer your question, Simran? Each week, so when you write your name, for instance, I write my name here. So I'm gonna be presenting week 12. That means the due date is when during the lectures of week 12. So during the lectures, most probably in the middle of the lecture, I will give you some time to present your to present this, or like if it is a video, we can play the video, things like that. So if wherever you write your name, that becomes your deadline. So that week, you need to, during the lecture hours, you need to give your presentation. Short, brief, beautiful, and um, um, you can make it even interactive at the end of the day. This Excel file? Ah, yeah. Well, actually, these are also these two slides I put on MS Teams. So here is the, well, this is basically what we just said. Nothing new. There's nothing new there. But for the links, if you go to this post and expand this post, you will see a lot of links. So these are each links to different websites, different news feeds, different parts that you can go see if it matches your topic, uh, your interest. And the rest is, so you just need these links. the there's no template basically, because we want you to be creative. There's no template for a presentation, but the general agenda is, okay, I'm this, I have done these and I'm interested in this. This is how much I know about this. It is fun, this is blah 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 blah, and I like it, and I want, and I will be I think I'll be doing this in the future. You're much more creative than I am, so just sky is the limit. Think about the ways you can present yourself and your interests. Does that make sense? Thank you. Okay, I guess we are good with this as well. Let me see. In the chat, we have topic of Himanshi is saying topic of that video. Topic of that video is I am advertising myself, my interests, and if I have my skills. That's the that's basically the topic. Uh, okay. How about a 10-minute break now? Because after that we will start our this week's lecture. This week's lecture, by the way, is an overview of different topics that we will be covering coming starting from next week. Topics. It gives you an overview of the ICT. Let's come back at 1:15. Okay, we'll see you uh, in basically 10 minutes. By the way, I'm here if anybody has any question we can discuss. Please come back. We will start with a poll. Please be here at 1:15. Thank you. And our class. Uh, so the first part is again emphasizing on on how important it is for you to think about your future and uh, think out of the box. Just look and find what is out there that is really appealing to you. So for these, you can go through all these links. Once I upload it today, you'll be able to check these in addition to all those links that we had. Uh, I've already posted on MS Teams, and these are also other links. So plenty of resources for making yourself an ICT professional. Please take a look and for the next week do this start doing this by uh, figuring out what is that you want to do. um, Computers, this the we have some interesting, very interesting topics here. They are a little bit advanced topics, but still these are the things that are going on in our real world. The first thing is, you probably hear it 10 times a day: AI. What is AI? Can somebody unmute and explain what AI is? What he, or at least what he or she thinks AI is? Exactly. It stands for artificial intelligence. So the next question is, what is artificial intelligence? If I see like, if I'm, what features should my application or my program or my whatever should have so that I can call it now it has an artificial intelligence embedded in it, or it is intelligent, it is smart, it is intelligent. What is it? Like if you're cooking, if there is an app helping you to cook, or if there is an app monitoring your health, which one is more smarter? And why would you say even, and what is the basics for this comparison? What is intelligence? What is the smartness? And why is it artificial? People, I know you know a lot. Just don't be shy, okay? Some people, please take out your sword. Nobody. Okay. So I try to basically answer this question from my point of view, and I try to think about what are the features that um, we can think about when we're talking about intelligence, uh, or intelligent or smart programs? Uh, you can add to this list, by the way. This is by no means complete. These are just my thoughts. So you can add to this. Applications or like programs or whatever uh, that can make decisions are some part of AI powered. Why? Because just like human beings, they can analyze different situations, and with the criteria they can make decisions like autonomous driving is is an AI powered, significantly AI powered application that these days car makers are talking about. So it is not just like a regular program, hello world program. It is just showing whatever you are programming in it, but also there is a mechanism that these programs uh, can analyze, and they have a criteria, they have a capability to analyze stuff, and they have a capability to decide based on the situation, choose like configure what is the best act. So this is one of the features. Another thing is learning. They learn. So machine learning, if you've heard, machine learning is also part of AI. Machine learning is how to how to teach a program, a bot, uh, a software bot you see these days when you start chatting with the customer service of a bank or an organization. Most of them are just bots. There's nobody sitting behind the desk answering your questions. So they learn. They basically learn from a learning data that you have to give to them. So the more data they see, the more intelligent they become. Google autocomplete is one of those, or in general, humanoid robots. These are the things, or like as I said, customer service bots. These are AI powered things or programs that can learn based on their experience, just like humans. Another thing is they can detect some stuff. So, and a very famous example is in image processing. You probably have seen they show a video or they show an image, and based on the that algorithm, now a human can be detected, and it is not mistaken with a monkey standing right beside that human. So how do they do that? This algorithm that is capable of distinguishing between humans and monkeys in a picture uh, is considered artificial intelligence, because this is not exactly what you're telling them to do. You're not telling them, okay, show this part of the image as human and don't show that part because that's a monkey, because I'm telling you. That's not intelligence, right? So I'm trying to give you an idea what AI is and what features our program should have to be considered a subcategory of AI. They can also predict. Prediction is based on their previous data and some criteria they have. They can predict. Like we have, like some of the apps that predict based on the long run data and what happened today. They can predict what happens in the future. Obviously, none of those predictions are 100%, but they can give you an idea. Anyways, this is one of the things that AI powered stuff, one of the criterias that they should have. What else do you think, guys? Do you think, can you think of anything else other than these four? Can you give an example of AI if you have a mind? No, you are AI. Basically, what is you are AI is a good sentence. It similarities that uh, the similarities that those programs have to our own, to human beings, basically uh, understanding, decision making, recognition, cognition, things like that. If your program has one or some of these, uh, it can be considered under the category of artificial intelligence and AI powered. What comes next is actually uh, what is next? Let me see. We have here blockchain. Still, we hear about this blockchain a lot. Why in heaven do we even consider this blockchain in our course, in ICT course? Anybody? No? Still, please don't be shy. Just whatever. Even if you think it's something that you've heard, let's discuss. No? I need to make a poll and see who is really sitting there. A blockchain, guys, in very summary, is a technique that allows you have several thousands to sometimes hundreds of thousands of computers distributed around the world, just like the internet itself, internet infrastructure itself. Um, for with a special technique of coding and encoding, um, these computers can keep the same data, and this is not just the whole story. This is the beginning of the story. Because what makes it a powerful tool for instance, transactions, for financial transactions, or crypto or whatever, is that you cannot change one of these documents without changing other 999 computers. So this is what gives it the power. It makes it secure for anything that happens. So you can either change all of those documents, update all of those documents with a new thing, with a new transaction, with a new happening, or with a new whatever, or none of them will be changed. So this is something that blockchain uh, is suggesting these days, and it's a powerful tool. You may These are the topics you may think of for your presentations, but this is not all the topics, obviously. Smart cities. Still, we hear about the smart cities, yet we probably don't exactly know what a smart city is. What do you think a smart city is? Come on, share your guesses, man. It's just we are talking about some stuff, some interesting stuff actually. No? Um, okay, let's. Smart cities, basically. When we talk about the smart cities, what is the first thing that comes to your mind? Oh, great. Yeah, wonderful. So it is some kind of more automated than cities that we're living in. Is that what you want to say, Vitaly? Yeah, kind of. So in this, thinking about smart cities, what comes to my mind is connectivity. So things are somehow connected. So cars are connected, the bank accounts, and things can talk to each other. It kind of think of some futuristic cities that we see in movies, what is very bold about these cities is, as Vitali said, it is some kind of automated. So you don't need to observe everything. There is no need for humans to just run things. Things can run themselves. And another thing is they are connected so that they know how to behave. Um so here, one of the topics that is very interesting comes to mind, which is, oh, let me see, which is IoT, Internet of Things, or other variations these days people are talking about, Internet of Smart Things or whatever. So IoT plays a role in making infrastructures smarter, like cities smarter. This can be an interesting topic, I guess. Neural networks is another concept. Have you heard of neural networks? Who can give some hint about neural networks? Neural networks is basically a model that has been mimicked from human brain, the way that we learn, the way that neurons are connecting, the way that their weights are changing, enabling our brain to learn things. So this is the exact same mimic that has been done, and with these neural networks, all these new things like deep learning, you see in the image processing, you see that that the application is capable of distinguishing short people from taller people, distinguishing very detailed things. That's deep learning used in image processing. So this is one of the topics you can just Google it, see how it goes for your future. Qubits, well, this is a hint. Quantum bit. Quantum bit. I'm not saying these are the topics you should be talking about, guys. These are not. These are just hints. These are the possibilities. Things that are out there and are at the edge of. All these things are at the edge of ICT, and people are working. If somebody can solve a very small issue problem that each of these have, they have a lot of problems that people are working on. If you can solve some of those problems, it can e- translate to money, immediate money. So think about these things. We are not just C programmers or C++ programmers. These are the tools that we should use to solve problems that are now at the edge of ICT. So these all questions. Qubits are quantum bits. So in typical computation, we have in the hardware level, if you think, we have 0 and 1 states. It is either 0 or 1. But so it gives you the logic, available logic so far has been binary logic, so you have to convert everything to 0 or 1. Qubits are quantum bits based on the rotation uh, of a quanta, the smallest, uh, like an electron. Okay, based on the rotation, the state, that state of that bit is defined based on the rotation. So this is basically, this gives you the qubit that can literally have millions of states, and that gives a super powerful quantum computers that people are these days talking about and are trying to build one, a real one. Another one, metaverse. It's interesting. Please, somebody that is interested in metaverse, have some experience maybe, can let us know what a metaverse is. Who has their own avatar in one of these possible metaverse worlds? Nobody? Go take a look. It's interesting. And how do new technology, how to do this? One good way is, at this stage, one good way is we can uh, practice joining open source communities. So by joining those open source communities, first of all, you will be contributing to those communities, and secondly, you can practice whatever you have learned. So one good way is to join those, because companies, you need to have skills, you need to graduate to be able to join a company to start working somewhere. But open source is always available. They're looking for people to contribute, and you can check this later. Check this slide. Links are embedded. This will take you to other websites. If you're interested, you can learn more about open source and how to contribute to that. Quiz questions will start from now on. The agenda is what we learn in the upcoming uh, weeks. Week 4 is a brief history of computers. I will try to make it useful, because if it is just history, it is not that useful. I'll try to make it a little bit more helpful and a little bit more related, so that you can relate to that and um, uh, pick up things that you need to know. Some definitions that we all are familiar with, except for uh, computer obviously is not the thing that is in front of you right now. It's not your laptop, it's not your PC. Computer is a very generic term, and that's why maybe in ICT we don't call them computers, we call them machines. And um, this machine can be uh, a, a small board, or it can be a mainframe, or it can be a computer that is used in a cloud, including thousands of CPUs and all that. But the minimum requirement for a computer to be called a computer is memory and calculation, the possibility to calculate. If something has a memory that you can store your data and can also calculate some stuff, you can load your program and get the output from that. That is the minimum definition for a computer, regardless of its shape, its size, its capability. Users, we know applications, operating system, and hardware. So there is this thing we need to know between application, operating system, and hardware. I'll try to draw here for the, okay, let me see. Uh, for the, I can draw it here. How about this? Okay. Okay, I'm trying to find something. I couldn't, so let me open Paint. That's the easiest thing we can do. All right, open up Paint, send it somewhere that the students can see. So we have hardware. We have hardware here. Uh, Hardware is the physical stuff, memory and uh, the computation part. Then we don't communicate typically. Well, we can, but typically in computer programming, we don't communicate directly with this. There is a layer about it called operating system, called the operating system. So this one is operating system. This guy here is operating system. This guy here is hardware, and the thing that you and I create when we are programming is this one. Is sorry, is this one. The thing that you and I create is this guy, is the application. So when you're writing your application, if you're not doing system programming, you are writing this part. So the interactions of your program is with your operating system. Memory, if you want memory, you have to ask operating system. If you are releasing memory, you're releasing this to the operating system. If you're printing something, you are telling the operating system to go ahead and activate your printer, your serial communication, your Bluetooth, your whatever. These are all done by the operating system automatically for you. What you're doing and what you have to know at this stage is the writing the application that communicates with the operating system, right? No more than that. That's why we are creating console application. What is a console application in C? That when you write your code and you see your the results coming up on the console. That's all Windows is doing. Windows is running that. Windows is opening console. It is showing you the result and everything. Everything is managed by Windows. There is another kind of programming, system programming or embedded system programming, that you also deal with their hardware. And that is another thing we need to see in this slide. If I can bring it up. Very good. So if you are programming, if you are this here, no, don't see that. If this computer programmer, yeah, I think I don't have a slide for that maybe. So when you're creating a software, you're creating something that connects and communicates with the operating system only. But if you're a system programmer, like kind of writing programs for hardware, sometimes it happens there is no operating system and you're just connecting directly to the hardware. Also, keep in mind a computer program is a set of instructions that are run one by one, are executed one by one. Your machine goes, reads first command, executes that, then goes to the second line, then goes to the third line, unless there is a jump somewhere. For instance, in looping or things like that, we have this jumping. And a computer program is just a set of these instructions, and source code, as we this is what we discussed. Source code, compiled source code is totally different with a source code. Let's see something here. You guys are with me? Let me first check. Is everything all right with you guys? Please let me know. Yes or no? Are we good so far? Probably need more answers. Let me take this there. Need more answers. Okay, good. Somebody said no. Vitali, can you ask your question, please? I guess you posted already. Yeah, I need to check this. Guys, sorry, give me a minute. Uh oh, we have a lot of replies here, guys. Unmute yourself. I see you replied to my questions in the chat. We don't see them. Okay, Vitali. Thanks so much. Thanks. Guys, it is wonderful that you're replying. This now I'm more happy. But please unmute yourselves and talk. We don't check this public chat part uh, frequently. Okay. Also, one good news is Seneca brings you the Linda that has been bought by LinkedIn. So go ahead, click on this. It will take you to Linda, or just you can just directly go to Linda and basically LinkedIn Learning now, and watch any course that you want. Okay, week 5, so week 4 we will talk about all these stuff. Week 5 is number systems and programming. Can somebody tell me what's let me show this. Can somebody tell me what's wrong with this slide? What's weird about it? What's so odd about it? Do you think it's odd, or like, did you detect anything weird? No? Everything all right? So one problem is this notation. How do you read this? Is this there are 10 types of people in the world? Let's say yes. And then you come down, see what is this? What is this? We have only 2 categories, but we say there are 10 types. So this is just a binary joke to show you the importance of understanding binary when you are programming. Some people ignore that, but it really helps you write very efficient codes in the future. So this, if you consider this a binary representation, this will be representing 2 in decimal. We will talk about these things. So first category and the second category, if we think binary, there is nothing wrong with this slide. If you think decimal, uh, it doesn't make sense. So we will talk about those number systems, especially binary, that you need to know to become a better programmer. Uh, we have other systems as well, like we have hexadecimal, uh, we have octal, we have binary, and these things. So we'll talk about all these, how to show a decimal point, how to show a floating point, IEEE standard, things like that, that you need to know about this to be able to write programs involving floating point things, float, double in C and C++, and know how these things work. Week 6, we'll talk about software development. As we said, as we know, oh, this is basically what I wanted to draw, but now we have a better demonstration. We have hardware operating system communicates with the hardware. Hardware can send queries to operating system, can ask basically, Mr. Operating System, now what you wanted is available. Go ahead and show this. This is the coming character, for instance. This character came from keyboard. Now go ahead and show this in the application that just requested that. So hardware can send queries to operating system. Operating systems can send queries. Operating system can say Mr. or Mrs. Hardware. I don't know. It's just like hardwares can be both men or women, male or female. Hardware, go ahead and go ahead and like uh, activate my Bluetooth. Go ahead and open Wi-Fi. Send this data for me, and then show me the acknowledgement that you did this. Return this to me. So basically, this is the bus. Operating system is the bus to the hardware. And then applications communicate with that bus, with the operating system. Whatever they want, they send a query to operating system, and they wait for operating system's reply or acknowledgement or reply data, whatever it is. And you and I, as users, we interact with applications. Applications are things that we work with on our daily basis. This program, PowerPoint program, um, Google Chrome, whatever you see is this this application. So you interact with your application. Application interacts with the operating system, and the operating system interacts with the hardware. Sometimes, as I said, we don't have an operating system, and that's what where programming becomes a little bit more tricky. You have to code, you have to have a code that can directly talk to your hardware, and that makes it a little bit difficult. We will just talk about this structure, not the bare metal coding. Week 6, as we said, we will talk about these things up. Okay, so system programming and software design. These are the two different concepts, as we said. System programming doesn't involve any operating system. It's just writing directly code that can run hardware. When you're designing software, that we will do is we are writing programs for the operating system to be done. I've already explained operating system. There is a concept, software development lifecycle. It might seem easy and simple, but when it comes to practice and you want to develop a real solution, a real program for a real group of people, um, sometimes these steps become difficult. Requirement analysis, sometimes this involves questionnaires and like so many observations to see what that group needs. Then you have to plan for that. Okay, I'm gonna solve this problem. I'm gonna ignore that. I'm gonna merge this problem. This is how we plan for that. Then architectural design for your software is how to, okay, what is the communication method you choose to communicate with your users? What are the other parts? Like, am I gonna have a backend? Am I gonna do where am I gonna do this? Am I gonna do all the processing in cloud, or is this gonna be a local computer? What kind of communication am I gonna have with other parts and stuff like that? So block level, different blocks. You put different blocks uh, for your solution that you have in mind. Then once your blocks are determined, those modules are known. Um, then you go and implement it. You code it basically. You develop this. You implement it with any programming language that you know, and then you test that. You test it based on what you know. After deployment also comes this. This is a loop basically. This never ends. This is the area that we see every day or every week or every month. A new update is being released for our applications. Why? Because the applications are deployed. Either the designer is adding new features, or there is a bug that has been reported by the user and that bug has been fixed. So you receive a um, basically an update for your application that fixes that bug. Uh, and in week 6, we will also look at version control. Version control, you have most probably heard about Git and GitHub. The version controls are basically devices that applications that let you keep track of your changes. So if you don't like your change, you can simply revert and go back where you were like 2 days ago. If something goes really wrong with your program, you can do this. So you need to have a software to be smart enough to keep track of these changes and keep fresh copies available for you whenever you want. And one of the best solutions is Git to use. Who knows about Git? And if Git is same as GitHub, is there any difference? Please unmute yourself and comment on Git and GitHub. who has heard uh, about Git? Like, who has heard this word Git, and who has not? This is a exactly. Exactly. So Git is basically that infrastructure, that application, that possibility that makes it possible to every time to commit your codes, and it takes a snapshot every time you commit. We'll talk about these, I guess. Every time we commit, it takes a snapshot, so it freezes everything and it keeps a copy, and each time you can come back to that point. So this is called Git, but there is a hardware requirement, a network requirement for this to run, to be available for everybody, and that is where GitHub comes in, and basically GitHub is that network that hosts this possibility, or GitHub. If you want more, there's a very good website about Git and GitHub. You probably need to just take a look at chapter 1, chapter 2, and chapter and GitHub chapter. I guess it's chapter 5. Take a look at these to figure out more about Git and GitHub. Very useful. We will need. Are we good so far? Any questions so far, guys? What? Let me know. You good? Okay. Week 7, we'll talk about client servers, network, and cloud computing in general, how networks work and things like that. And the most important thing is to know this hierarchy uh, from from edge devices, whatever that you and I are using. These are edge devices. One level about this is fog. These are routers and switches that make it possible to route different queries to different servers, and this is basically uh, the the cloudy part, because from your uh, edge device, but anything about your edge device, we don't know what is going where. This is typically somewhere that we don't know. That's why we call it cloud. This is foggy. This is cloudy. We just know that we are sending something, but we don't know where it goes, in which server exactly it gets calculated and then comes back. What we see is just something went out to the cloud and came back. That's why it's called cloud. But it's literally not something. It is kind of magic. It is a connection of all these machines that we don't know where they are, we don't know who they belong to, and we don't know how they work, but we just want to take advantage of them. Uh, and is uh, one concept is typically this is a question that you want to do your calculations uh, in these servers, the cloud computing or edge computing. Um, can somebody speak about the difference between edge computing and cloud computing? Differences, pros, cons. Exactly. That's the difference. So when you are, for instance, when you are using calculator on your uh, phone, this is edge computing. The hardware of that phone is doing all the calculations and everything for you. But when you are doing the exact same calculation using an online website, for instance, you enter your data is sent to the cloud. In the cloud, everything gets calculated, the result, the result is sent back to you. So there is a there is a huge controversy conversation going on when to use edge computing and when to use cloud computing, especially under concept of IoT. People are saying, okay, now we have all these smart devices. Do we need to do all the calculations? Imagine there's a device is deployed, uh, a camera, like a camera, surveillance camera somewhere. Do we need to all do all the calculations in that camera and send the result to the cloud, or no? We can rely on our communication lines and send the image. It can get the cloud will process that and will send the result, action, whatever it is, uh, to the node again, back to that camera or to that node. So here, a concept that we should know comes up, which is latency. Latency is basically the time it takes it takes from the time you click send, or the application itself sends some data to the cloud to be processed, and then the cloud sends back an acknowledgement. Okay, Mr. Node or Mrs. Node, I received your uh, query, I received your information, and I am processing it. That is latency, and it becomes very important that people are now spending billions of dollars on building 5G and 6G. The main difference between these network communications and type of networks between 4G and 5G is latency. Mudit, any questions? Yeah, Miss Click. So just want you to compare the time that it takes from our eye to our brain for the signal to go from our eye to our brain is about 10 milliseconds. So it takes 10 milliseconds for the brain to actually see the image that I saw 10 minutes ago. Sorry, 10 milliseconds ago. Now in 4G, the latency is around 15 milliseconds. So if a car wants to know if it is safe to go ahead, or if it is not, if it needs to brake or do something, if it wants to send the information, radar information, whatever image, to cloud, it will take 15 milliseconds for the acknowledgement to come back, and it will take some time. Well, actually, cloud is fast, so let's say immediately it will send back the result. Another 50 millisecond, 100 millisecond will take for the car to know if it should speed up or if it should brake. Now in 5G, it's less than 10 milliseconds. People are talking about 1 millisecond, which is huge. So it is even, imagine if you have a 5G, if a car has a 5G, communicating to the cloud takes 1 millisecond for the data to go and 1 millisecond to come back. It's even less than the time that your brain requires to receive the image that your eye sees. It is a significant thing, and that's why it's so much challenging and people are working. So this latency, so now you can imagine with shorter latency, why is it important? With shorter latency, you can rely on cloud computing more than your edge computing. Why? Because now it's almost immediate. It's almost your device is connected to the cloud, and if that cloud is not busy with something else, if you have a powerful enough cloud, of course, then you can all the computation can you can rely on that. So this way you can make things cheaper. If you have a car that wants to do everything by itself, you have to add a lot of hardware to that, right? A lot of systems that can calculate. Like, it should be a really powerful computer. Your car should be a computer. But if you can rely on cloud computing by better networks, low latency, stuff like that. You can have, you can control, you can have a better control on edge, and things can become cheaper. This is one of the things. There are many aspects to this actually. Uh, so there is a video here. Please go ahead and watch this. This is showing how magic is each of these clouds and basically data servers, stuff like that. Please go watch this. We're not gonna see it now. Um, and week eight, we will be talking about different interfaces. Uh, the most common interface, of course, is the graphical user interface, or GUI. Graphical user interface is all those interfaces you and I are now communicating with. Um, all these visual windows that are open, uh, being able to select things using your mouse and everything else. These are graphical user interfaces that are most popular because they are, of course, they are the most easy to use. But we have two other kind of interfaces that come handy actually when we are programming. One of them is command line programming. Command line programming takes place uh, in console. If we are on Linux, takes place in command window or PowerShell. Later, on later versions of Windows, they basically try to mimic what Linux has as a command line communication. So you look at this now. Let's go back to this slide. You as a user, you as a user are communicating with the application, and that application is communicating with the operating system. Sometimes you communicate with the operating system directly, right? When, for example, creating a new directory, a new folder, you're creating something, or like opening a file. There is no application in between. You're directly uh, communicating with the operating system. This can be visual, as like you go right click mouse or keyboard shortcuts, stuff like that, or it can be through writing a code in command line. So this comes very useful and very handy when you're, especially when you are experts in programming. Uh, Sometimes can save you a lot of time. And this is basically not a graphical window, but a, a, an interface that allows you to write your commands, and those commands uh, are processed with the operating system, and the result again is shown to you in the format of text. So this is also one of the popular things that we will discuss. Another interface is this P2E, plain text user interface. Can somebody unmute and tell me if where they have seen this kind of interface, and if they have seen? Where? Italy? You haven't seen this one. Anybody that has seen this one? Have you ever broke your laptop or your PC, something you need to install operating system or do something? No. Exactly. Yes. Yes. Of course. No, I of course. Yeah, of course. That's why this is history, and we will not talk a lot about this. But still, you might see this kind of interface in some of those laptops. Yeah, but thank you, Italy. Exactly. This is what people usually see in BIOS, right? When they enter their BIOS of their computer. Um, uh, week week 8, still, we will have to talk about time management, some concepts about time management. And week 9 will be file compression and backup. Basically, why the reason we compress files and how we compress those files is simple. We want to make programs occupy less disk space. That's one main motivation to do that. And another one is when you zip a file, all the files, hardware wise, all the files get together in one location. That's why it takes less time to upload a zip file or download a zip file. Uh, but zip files, you have to unzip to be able to work on them. If you cannot basically work with a file in its zip format. So we'll talk about these things, and also backups. We briefly talked about backups on week 1, and I introduced you to OneDrive, or some of you already knew and already used. So this is a good backup because it literally synchronizes all the files and it stores them in a geographically remote area. So if something goes wrong with your laptop, you still have that server somewhere in the cloud. We don't know. It might be in North Pole and it might be in some other country. We don't know where, but we know that it is safe and it exists there. Week 10 is about authentication and authorization, security, basically related things. So we'll talk about these. What is the difference between authentication, authorization? Authorization is basically giving access levels, stuff like that. And Also, we will start week 11. We will start with our final project. Week 12, we'll talk about the differences between closed and open source softwares, how you can get license for your own software and stuff like that. Um, uh, by the way, we all know that, for instance, Windows is not an open source; it's closed source. So when I get the files, Windows files, and when I install them, what is that I have? So if it is closed source, how come I have those files? Can I go like see? Can I go and like open those files, see what's inside, and do something, modify? Anybody? Any idea? What is the difference? So let me ask it this way. We know that Firefox is an open source software, but uh, Google Chrome is not. I guess no, it's not. So when you receive the files from Firefox and Chrome, what is the difference between these two files? Yeah, exactly. So this is what you have basically. Uh, when it is an open source, you can see the source code which is readable for you. Let's go to a project that I wanted to show the difference between build and compile we created last time. So this is my this is my code. This is my source code. This is what I have written, the source code. I'm opening it with a notepad. If you open this with a notepad, this is what you will see. This is readable code, everything clear, life is good. I have this, everything perfectly fine. Now, let's go and look at the executable file or the compiled files we have. If I go to debug and Open the executable file again with the same notepad. Oh, oops. See, now this is the code that has been built. Okay, let me see if I can do this. Yep. Now compare this code with this one. Guys, this is surprising, but literally these are zeros and ones created by our Visual Basic compiler with our C compiler and linkers and final solution. These are zeros and ones because these are non ASCII codes. Your notepad shows them this way, but these are literally zeros and ones that that gets loaded to your CPU. These are instructions, line by line, get loaded to your CPU and got executed. Let's see, for instance, if I can find this piece of so this code I guess, oh, it's a C++, but it doesn't really matter. This is let's say C code that wants to show compiler build. If I run this, it in a console it says compiler build, simple output, just an output. So if I look for this in the other file, control find, paste, see where it is. It is somewhere embedded in all these zeros and ones, and this is exactly the output of the program that that is shown in the console. But the rest is, for one of them is like the first part, the beginning part is this library thingy you have written here, and all other codes. It tells uh, CPU what to run, what not to run, things like that, things that you and I just don't understand. It looks gibberish. So for open source, we see this version of the program that we receive as well, and we can even go ahead and modify this code, compile it, and have a new version of the software. We can share with the community. Everybody can do that. So this is open source. We know what the source code is, and we can modify that. But for the applications that are not open source, like Windows, whatever you can think of, like Photoshop, whatever is commercial is not open source, you receive this kind of files. You don't know what's inside, but your computer knows. So these are compiled files that you can easily install using go through those instructions. There's an installer. There is no source code for you. You have the installer. Installer runs these pages one by one, and it gets installed in your computer. So this is a big difference. If you look at this, you can never understand what's going on in the source code, and that's the difference between open source and closed source. Open source is though dangerous if there is not a tool to track the changes that people make to it. Uh, they can become uh, dangerous, malwares basically, or other kind of things, because anybody can write anything that they want, and if you just execute it blindly, uh, this will result can result in catastrophic things. Are we good with this difference between open source and closed source and stuff? Uh, Time for a poll. And so, are we good with this difference between open source and closed source? People, more people. I know you're tired, but I also know that some of you are excited and some of you are only tired. Guys, Okay, good enough. Thank you. Um, so the next thing we will be talking about is this, yeah, intellectual property, how to get a license, if you need a patent or not, and that will be the end of this course. An overview here. So I hope uh, we learn a lot of things, fundamental things for your career, hopefully, and that's it basically for today. Uh, if you have any questions, again, I will post this lecture notes quickly today, and also you will see activity 3, which I just explained before slides. It's easy peasy. You just need to think about this. Um, Go ahead, check websites, and think about it. That's it. Any questions? No? Okay, then have a wonderful week. Let me know if you face any problem on Microsoft Teams. Thank you, and we'll see you. Mudit, sorry. Yeah, no, sure, go ahead. No, no, it's only activities, quiz, and the final project. There's no midterm or final exam. Yeah, you go to our MS Teams. Oh, sorry. Our MS Teams, and here I've posted uh, an Excel sheet. You just click on this, just type your name, yeah, wherever you want. When in like different groups, different weeks. That's right. Yes, it's basically a presentation about yourself. You can um, and gives you an opportunity to think about all these stuff. Thank you. You too. Okay, guys, we'll see you next week. Sorry, pardon me, Mudit. Okay, see you then. Bye.